Okay. So the next one that we have here is we have logarithm base 4 of x minus 1 plus logarithm base 4 of x minus 2, which equals to 1. And so we're going to try and solve for x here and state our restrictions. So the first thing we could do is actually do the restrictions. And we can say for logarithms, whatever's on the inside of the logarithms cannot be equal to 0. So that can't be equal to 0 and that can't be equal to 0. And so if that's true, we're asking ourselves what makes this inside part 0 for this first term. So that would have to be 1. So as 1 minus 1 would give us 0. And similar, we have to also restrict x being 2, because for the second term here, if we had 2 minus 2, that would give us logarithm of 0, and we can't have that. So these are our restrictions just to get us started. And we need to now solve for what we have in terms of x. So the first thing that we could do is, because we have two terms with x in it, I can combine them using one of the log rules, which is at the bottom of your page uh, somewhere. Here they are, the log rules. And it's saying that if you have the sum of two logarithms that have the same base, so base b and base b, you could write that as just one logarithm using as a product of the two. So I could say that this here is the same thing, or equivalent to, logarithm base 4 of x minus 1 times x minus 2. So that's all inside one logarithm now, and that's still equal to 1. And I think I mentioned it before, but 1 can be rewritten as any kind of logarithm we want. So 1 can be written as like log base b of b, because where b is any number, because logarithms are just basically asking you um, some, maybe like an example like this. We have log base 2 of 2. It's asking you 2 to what power will give you 2? And the answer is going to be, well, that's 2 to the first power is the same thing as 2. And so in other words, it's always 1. Or if we had like 4 to what power is going to give you 4, or 5 to what power is 5. It's all going to be the same. And so using that here, we're going to use that rule, which is also at the bottom of your page, to rewrite 1 as logarithm. And we can choose base 4 because we have base 4 on the left side. So if I make this the same, now basically I'm saying to myself, well, if these two are the same, the left-hand side and the right-hand side is the same, then 100% whatever is inside these logarithms, so what I'm highlighting in yellow, have to also be the same. So we can go to the next line and say that x minus 1 times x minus 2 has to be equal to 4. And if this is true, I can expand this and I'll have some quadratic, and we need to solve for that quadratic again. So we're going to do that and solve this like we normally do. So we're going to FOIL this out. I get x squared minus x squared minus 2x minus x plus 2 is equal to 4. And then these like terms will be just become minus 3x. And then if I move this 4 from the left, or from the right to the left side, I'll have to subtract 4 on both sides, and that's 2 minus 4. So it's going to be minus 2 equals 0. And so I have some quadratic that I need to solve. And just like before, in the question above, we can just use the quadratic formula to solve this. Or you could otherwise factor it. But I'd rather use the quadratic formula because I find it's easier. So so here our a value is 1, our b value is -3, and our c value is -2. So x is going to be equal to the following here, just plugging everything in. 3 squared minus 4ac divided by 2a. And now we just need to simplify this. So inside of, or outside of the square root here, this first term is two negatives, so that's just going to be 3. Plus minus, -3 squared is just going to be 9. And we have two negatives again that are multiplied by each other. So it's just going to give me a positive 8 times 1 times, 4 times 1 times 2 is going to give me 8. All divided by 2 times 1, or 2. And I'm going to move over here. X is equal to 3 plus or minus the square root of 9 plus 8 is 17 divided by 2. So just like before, we get two answers. One is for when it's positive, and the other is for when it's negative. So this would be the exact answer that we get for question number 26B. And then we're going to do the other one for 26B. So I'm going to just get all of this erased. So we'll start here. And we have exponents now. So it's kind of the opposite of logarithms, or it is the inverse of a logarithm. And so we have this 5 here, and then 8 here. So first thing I'm going to do is I'm going to rewrite this so that I have all of the 5s on one side and all of the 8s on the other side. So to get rid of this 5, I have to divide both sides by 5. And when I do that, the 5 is going to be gone on the left, so that I'm just left with x, or 8 to the x plus 2 power, which will be equal to, we have something here where we have two 5s as our base. And one of the rules here for exponents is that, or one of the exponent rules is that whenever you have something divided by another exponent, and in this case it's 5 to the power of 1, your result will be just the difference of those two exponents. So it's going to be 5 to the 7x minus 1 power. And now I need to continue solving, but right now these x values are in the numerator, in the exponent of these exponents. So I need to get those brought down so that I could do like the regular algebra. And so to do that, we could use a logarithm rule, which was that if you take the logarithm of some exponent, so like x squared, that exponent can go to the front, or some term that has an exponent rather. The exponent can go to the front, and we'll write this as 2 times logarithm of x. So this is also a rule that's written for you on the bottom of your equation sheet. So doing this one, if I take the logarithm of both sides, logarithm of 8x plus 2 equals logarithm of 5, 7x minus 1. And then taking what we have in the top and bringing it to the front will give me x plus 2 times the logarithm of 8 is equal to 7x minus 1 times the logarithm of 5. And so now I need to just solve for x as I normally would, and then I'm done this question. So I'm going to expand this logarithm of 8 and the logarithm of 5 into the terms that we have here. So I'll have logarithm of 8 times x plus 2 times the logarithm of 8 equals 7 times the logarithm of 5 times x minus the logarithm of 5. And now I need to get all of my x values onto one side. So I'm going to move this term over here so that I have both x's on one side, and then I'm going to take this non-x term and I'm going to move it the other way. So that will give me a logarithm of 5 now on this side, and then the other term, which was the log of 8x, is now on the right side. So this right side is where I want to work with now, because I have the x that I want to isolate for, and because it's being multiplied to the first term and the second term, that's a common factor to both. So I can just say this is the same thing as x times 7 log base 5, or 7 log of 5 plus log of 8. That's all on one side. And then we have something on the left which stays the same, log of 5 plus 2 log of 8. And so my value for x, I just need to divide both sides by what I have here, 7 log of 5 plus log of 8. So that cancels out, and I do the same on this side. 7 log of 5 plus log of 8. And so that's my final answer. I'm just going to rewrite it though, so it's a bit clearer. That x will be equal to log of 5 plus 2 times log of 8 divided by 7 log of 5 plus log of 8. So that's the final answer here.